now it's time to take a look at a different way that the velocity can change. And this time we're going to look at a motion that actually has a constant speed. So before the magnitude of the velocity was changing. Okay? But now let's say we have something where we have our velocity, and we'll look at it in two dimensions. So we'll say it's Vx, x hat, plus Vy, y hat. Okay? So an example of this would be something like if we look at like uniform circular motion, which we talked about back in the calculus unit. So we said that we have this velocity that's always the same. Magnitude v. But now in this case, notice that the velocity is actually pointing in a different direction each time, right? So in one case, the velocity is v y hat. In another case, it's minus v x hat. In another case, it's minus v y hat. In another case, it's v x hat. All right. So what's changing isn't the magnitude of the velocity; it's the direction, and that's true because velocity's a vector. And we already looked at this case, but it can be more complicated motion. We can have something that's moving at a constant velocity, tracing out a path like this, so that at each point in time, our velocity is still the slope, the tangent of this curve. So you may remember that from your calculus class. Like at any point here, this is the velocity. So even if it's at a constant magnitude, the velocity is changing every time because the direction is changing. And so because that's happening, that means there has to be an interaction. That's the key. That's the important thing to remember here. Is because velocity is changing, there's some interaction. And interactions are what we're going to spend the rest of this unit and most of the rest of this book on, is what those interactions are and how we can quantify them.